In this video, we're going to look at angular and linear speed or velocity. Again, this is going to be an exercise mostly in dimensional analysis or unit cancellation. So when we think about angular speed, we're going to be talking about angular units over units of time. So angular units are either degrees or radians, and then time units, obviously minutes, seconds, days, etc. When we talk about linear speed, this is speed that you're used to, miles per hour, feet per second, something like that. So linear units, there are a multitude of them. So we could have kilometers, we could have feet, we could have miles, inches, etc. Again, over units of time, minutes, seconds, days, hours. So in this first example, a Ferris wheel at the county fair has a diameter of 14 meters and makes 1.2 revolutions per minute. We're going to determine the angular speed in radians per minute and the linear speed in meters per minute. So in this first one, we always want to start with this information here. So they're going to give you some sort of rotation or revolutions in a matter of time. So this one is 1.2 revolutions over 1 minute. So always kind of write it in that fraction form, and then we can start working to get to radians per minute. So we need radians on top, but we have revolutions right now. We need minutes on the bottom, so my denominator unit is perfectly fine. So I really just need to multiply by something to get rid of a revolution. So I need revolutions, and I want to change that into radians. So 1 revolution is a complete circle. 1 time around a circle in radians is 2 pi. So 2 pi radians is the same as 1 revolution. Then I can cancel the revolutions. And then we've got 2.4 pi radians per minute. If we multiply this out, we would go 7.54 approximately radians per minute. So then getting into linear speed, we want meters per minute. So again, I'm going to start the same way. 1.2 revolutions in 1 minute. Again, I want to get to meters per minute, so my denominator is perfectly fine, but I need to multiply to get rid of the revolutions. So again, 1 revolution. So 1 revolution is 1 time around a circle, which is equal to a circle's circumference. So 1 revolution is the circumference of a circle. So it's important to remember that. So I'm going to rewrite this. This is 1.2 revolutions in 1 minute times, so my circumference, if my diameter is 14 meters, is going to be 14 pi meters over 1 revolution. So remember, this has to be equal, so 1 revolution is the same as the circumference. So at this point, I can cancel the revolutions, and now we have 16.8 pi meters per minute. Or here we could say 52.78 meters per minute. All right, so looking at another example here, we have a truck that has wheels 36 inches in diameter. The wheels are rotating at 630 RPMs, which is rotations or revolutions per minute, and we want to find the truck speed in miles per hour. So remember, we always want to start with this, revolutions or rotations in 1 minute. So we've got 630 revolutions in 1 minute. So now we need to get to miles per hour. So let's get rid of the minutes into hours first. So I want to get hours. I want to get hours in my denominator, so I can convert easily. 1 hour is 60 minutes, and then we can cancel out the minutes. So now I've got hours in the denominator, which is what I was asked for. So we're finished with the denominator part. So now we want to start converting revolutions into miles. So remember, 1 revolution is the same as the circumference. So again, I'm going to go back here to my 36 inches diameter. So that's going to give me a circumference of 36 pi inches. So my circumference is going to end up in the same unit as my diameter was given in, inches per revolution here. So now I can cancel out my revolutions. So now we've got inches over hours. So now I just need to get inches into miles, which is just simple conversions. So let's change inches into feet, because we know that conversion. So we know there's 12 inches in 1 foot. And then we can convert feet to miles. And there's 5,280 feet in a mile. If you needed that conversion factor on a test, I would give it to you. and then we can cancel out the feet. So now if you look, we've canceled out every unit in my numerator except for miles, and we've canceled out every unit in the denominator except for hours. So we've got miles per hour, which is what we're looking for. So now I just need to do the arithmetic, and I can use my calculator to do that. And we get about 67.47 miles per hour. Another example here, we have a radial arm saw that has a circular cutting blade with a diameter of 10 inches. It spins at 200 rotations per minute, and there are 15 cutting teeth per inch on the cutting blade. We want to know how many teeth cross the cutting surface per second. So again, we're always going to start with this. So we've got that rotations or revolutions per minute. So here we've got 200 revolutions in 1 minute. We're trying to get to how many teeth per second. So I want teeth on top and I want seconds on the bottom. So I'm going to deal with that seconds first. So I want to get seconds on the bottom, and so I can convert that and get rid of the minutes. So I know there's 60 seconds in 1 minute. So now we've got our seconds taken care of. So now we want to start converting to get rid of the revolutions. So 1 revolution is going to be equivalent, remember, to my circumference. And I have a diameter of 10 inches, so that's going to give me 10 pi inches. And then we can cancel out the revolutions. Then we have sort of an unconventional conversion here. So we need to get rid of the inches, and we need to get to the cutting teeth. So I can put inches on the bottom, and then this would be teeth on the top. So we can cross out the inches. And here we know there are 15 teeth per inch. So 15 teeth in 1 inch. So now again, we've canceled out everything in the numerator unit-wise except for teeth. We've canceled everything in the denominator except for seconds of my units. So teeth per second is what we were looking for. And then again, all I need to do then is to do the arithmetic here so that I can get my numeric answer. And we should end up with about 1,571 teeth per second.